Hey class, we're going to go into 12.1 today, so let me go ahead and bring this up. Oops, not the right way. So let me go to sharing. Hold on just a second. Okay, so let me go to the beginning of the slideshow. Okay, so we're doing 12.1, scatter plots and correlation. So let's look at some items. Okay. So our first slide is talking about, we're going to look at some data for relationship between base salary of NFL quarterbacks and the number of touchdowns the quarterback has thrown in one season. So think about it. We have two sets of data. We have the number of touchdowns, and we also have their salary. So we have an X and a Y. So go back and think about algebra. When you put a line on a graph, you had to have, for the points, you had to have an X and a Y coordinate. So let's look at this and go, so we're going to think about, do you think there's a relationship between base salary and the number of touchdowns? So to see if there is, what we can do is we can take data and plot it on a scatter plot. And you've done this before. You've done this probably through middle school and high school, where you had values that had an X and a Y and you plotted them on a graph. So here we go. So this is what it looks like. So we see number of passing touchdowns is on our X-axis. Salary in millions of dollars is on our Y. And again, these are number lines. This is quantitative data because we can't do a linear regression with qualitative data. Okay, looking at this graph, I don't see a lot going on. It's kind of scattered. So we can say that because we don't see a linear pattern, that this probably indicates that there's not a relationship. So let's look at data in 12.2 that shows a relationship between the number of touchdowns thrown in one season and the corresponding quarterback rating. So we'd expect the number of touchdowns to influence the quarterback rating, so we're probably going to see a sharp correlation. So if you look at here, I plotted on the x-axis the number of passing touchdowns, and on the y, the quarterback rating. So if you start seeing along this on this graph, you'll see there a line is kind of forming. It's going up in a direction. So we're going to say, let's go back and look at it, that it's going from left to right and increasing. So we're going to say there's a positive slope. Do you remember slope from algebra, which is rise over run, or the change in y over the change in x? We use slope for this too. So let's talk about determining if we have a positive, negative, or no slope. So let's look at the relationship between the number of hours you study for an exam and the score you make on the exam. So without saying, hopefully, the more you study for an exam, the better you do. So that would be a positive slope, because as the number of hours increase, so does your score on the exam. B, the price of a used car and the number of miles on the odometer. So when you take a car off the lot, say we're doing a new car, and it was $20,000, each time you look at it to see, like say you look at the first year and you drove it 10,000 miles, the price of your car is going to drop because of that. And if you look at it 2 years from now, and if you drove 40,000 miles more, your price is going to drop a lot. So the more you drive a car, the price decreases because of the mileage on it. So that's a negative slope. So you can see the pressure on the gas pedal and the speed of the car. So think about when you're in the car. You press on that gas, what happens to your speed? It increases. So that's a positive slope. So for the last one, shoe size and IQ for adults. Well, shoe size really doesn't determine anything. That's more of an indication of height and everything, but it has no bearing on your IQ. So that would be no slope. Okay. And if you need more information, here's the written out part of what I just said. So one way, an easy way if we can't graph it, is to look at the Pearson correlation coefficient. And that's a parameter that measures the strength of a linear relationship between two quantitative variables in a population. So that P refers to the population. If we're talking about a sample, we're talking about the correlation coefficient for a sample is R. And it always takes a value between -1 and 1. So I want you to think of it this way. I'm going to insert a new slide. Okay, so for the correlation coefficient, -1 means a weak negative, means a strong negative relationship. 0 means no linear relationship. +1 means a strong positive linear relationship. And then you need to go back up here to the negative and add linear. Okay? So let me give you some examples because it's never really going to be -1 or 1. So let's look at -0.35, 0.264, or whatever. So this means a weak negative linear relationship. Okay? Because it's negative. See the negative sign in front of it. And anything between, I would say, -0.5 to -0.300 would be weak negative relationship. 0.31000 to 7.700 negative, sorry, let me keep putting that negative in there, would be a moderate negative relationship. And the final one, above -0.700 to -1 is a strong negative relationship. Okay? So you can change these negatives to positives, and the only thing that's going to change is negative. Negative would change to positive, and that's all that changes. So think of it as a scale that way. Okay? So let's keep going. This is Pearson correlation coefficient. It looks nasty to figure out, but we don't really have to worry about it because, well, guess what? Our calculator does it. So let's go back to that data where we're relating touchdowns to base salaries. Here's the data, okay? So let me walk you through how to do this. On your calculator, we actually have directions next. You might want to pause this and come back, or you might want to open the PowerPoint while I go through this so you can look at it. Okay. So we see our x-axis is the number of passing touchdowns, and our base salary is our y. To put this in the calculator, go to Stat, go number 1, which is the Edit button. In L1, put your x values, and in L2, put your y values. Press Stat, calculate, choose option 4, and hit Enter twice. This is what it will bring up for you. The only thing you need to worry about right now in this video is the R at the bottom. So we're seeing R equals -0.250601335. Well, if R is -0.251, that means there's a weak negative relationship. Okay? So between salaries and quarterback, or touchdowns versus salary, there's a weak negative relationship. So then let's look at it for touchdowns and quarterback rating. If we go ahead, and here's the data, and there's the scatter plot, if we put it in our calculator, again, do Stat 1, put the values in X, the values in Y, press Stat, calculate 4, and then hit Enter twice, then this is what it gives us. It gives us that our R, if you see at the bottom, is 0.92541951178. That is a very strong positive correlation. So we can say that there's a relationship between touchdowns and quarterback ratings. Okay, I'm going to stop here. So you want to play with your calculator. If you have any issues with it, write me or look at the calculator guide that I put for Chapter 12, and it should help you. So have a great day. Bye.